What is up, everybody? Juan here from Playing Games Podcast, and today I want to talk about stretch-activated ion channels. Now, you've probably heard this term before when you hear people talking about muscles fatiguing more at longer lengths because the stretch-activated ion channels are opening up. That's exactly what I want to go over today, so you can get a better understanding what these ion channels are and just the general idea of the topic. So, the contents that we're going to go over today are what are ion channels, because there's a variety of ion channels. What are stretch-activated ion channels specifically? What activates stretch-activated ion channels? The activation mechanism, which is not yet fully understood, but we do have a theory, and their role when it comes to contraction and fatigue of the muscles. So first things first, what are ion channels? Well, to first understand what ion channels are, we first need to understand their location, which is the cell membrane. The cell membrane is a complex structure composed of lipids and proteins that separate the inside of the cell from the outside environment. So they're made out of these phospholipids, which look like jellyfish, right? So think of like a round head, and then think of two tails coming out of it, just two tails. And these tails are fatty acids, right? So the head is hydrophilic, which means that it likes to be around water, while the tails are hydrophobic, which means that they do not want to be around water. So when you search up the picture of a cell membrane, you're going to find this lipid bilayer, because there's going to be two layers. And on the outside surfaces, you're going to see like these balls, right? And these balls are the hydrophilic heads because they like to be around water, because on the outside surfaces, there's going to be water in and outside of the cell. And then on the inside of the cell membrane, you're going to see the tails kind of just like touching each other. And they're going to be away from the water because they're hydrophobic. They're scared of water. They don't want to be near it. So transmembrane proteins are proteins that contain or that come together to form either a single or multiple water-filled channels across the membrane. All transmembrane means is that it spans across the entire width of the cell membrane. So the cell membrane, it's important to understand that it's semi-permeable, which means it's very specific to what it allows to go through it or in and out of it. Ion channels differ from pores as they open up transiently in response to various stimuli like membrane potential changes, ligand binding, and more. So there's different types of ion channels, and they're going to have different structures, which means that they're going to respond to different stimuluses, right? Some of those stimuluses will be the membrane potential changes, and others would be the ligand binding. And a ligand is just the binding receptor molecule. And this is going to allow small ions like sodium, potassium, and calcium to pass through the lipid core of the membrane. And this is also known as diffusion. A more specific term for diffusion would be when ions flow from an area of higher concentration to an area of lower concentration. So that just means if there's an area that has a lot of ions of a specific ion, and then there's another area that has very little of that specific ion, these ions are going to want to go to the area with very little ions to create this balance of ions, or this equilibrium and this homeostasis. So what are stretch-activated ion channels? Well, stretch-activated ion channels are also known as mechanically gated ion channels, and they're a type of mechanical or mechanosensitive ion channel. They play an essential role in mechanical transduction, which is the process of cells converting mechanical stimuli to electrical or chemical signals. Basically, it's a very important process when it comes to hypertrophy or muscle growth. And stretch-activated ion channels are permeable to a variety of ions, including sodium, potassium, and calcium. And again, permeable just means that they allow these ions to flow through them. Stretch-activated ion channels can be found in the plasma membrane of various cells, including muscle cells, epithelial cells, and neurons. Epithelial cells are cells that can be found on the inside and outside of the body, like your skin, blood vessels, and organs. So the specific effects of stretch-activated ion channels on ion influx, and an influx is basically just like an entry of a large number of things, and cell signaling depend on the specific type of channel as well as the cell type and physiological context. What activates stretch-activated ion channels? Well, stretch-activated ion channels are activated by mechanical stress, right? Mechanical stretching of the cell membrane. See, a lot of people think that the cell membrane is like this rigid wall and structure. It's actually not. It's actually very dynamic and fluid, and it can actually change structure. When the cell membrane is physically deformed or stretched, which it can be, stretch-activated ion channels respond by opening and allowing ions to flow across the membrane. This is thought to play a role in physiological processes like sensation, hearing, touch, as well as the regulation of cardiovascular and respiratory function. So they don't just have a role when it comes to muscle fatigue or just muscles in general, but they have a very important role when it comes to our senses. Now, what is the activation mechanism? Well, the exact mechanism by which stretch-activated ion channels are activated is not yet fully understood, but the theory is that mechanical stress caused by stretching of the cell membrane leads to a conformational change in the stretch-activated ion channels that opens the channel, allowing ions to pass through the membrane. Again, the cell membrane is this semi-permeable structure that is very specific to what it allows to flow in and out, and that's why there's these different stimuluses that can activate these ion channels to allow certain ions to flow in and out of it. So the conformational change is thought to be caused by changes in the tension of the lipid bilayer, as well as the distortion of the cytoskeleton and other proteins attached to the membrane. The cytoskeleton is just this complex network of proteins. So, what is their role when it comes to contraction and fatigue? Well, when a muscle is stretched, the mechanical forces cause the stretch-activated ion channels to open up, allowing an influx of sodium ions into the muscle cell. This influx of sodium ions can actually trigger the release of calcium ions from the sarcoplasmic reticulum. However, there's a caveat. Too much influx of sodium ions can inhibit the entry of calcium ions into the cell, causing the muscle to become less responsive and possibly stop contracting, and this can impact mechanical tension. Mechanical tension is one of the main drivers of hypertrophy, at least to our understanding at the moment. And so if this is impacting the muscle's contraction, then that means it can impact the muscle's tension or the mechanical tension that's occurring in the muscle, which could then impact the signal or the, hypertrophy signal the muscle would be receiving. So the opening of stretch-activated ion channels can have both a positive and negative effect on muscle function, depending on the degree of mechanical stress. So pretty much it depends on the context. They're not bad nor good. It just really just depends on the degree of mechanical stress occurring or that they're sensing or receiving. And that's basically it. So I hope you guys were able to understand or get a better understanding of what stretch-activated ion channels are. So when you hear the term again, you can have a greater or just better general idea of what's being talked about. So as always, make sure to like, subscribe, and follow us on Instagram at Coach Juan and at Deltoid Factory for Jack. And as always, if you have any questions, just make sure to drop them in the comment section below and I'll gladly answer them. Thank you and see you next time.